Bromate ions act as oxidizing agents in acidic conditions to form bromide ions. Deduce the half equation for this reduction reaction. Well, first let's break it up into some simpler parts. First of all, bromate ions. The bromate ion would be given to you someplace before in an earlier part of this question, and that is BrO3 minus. Here you see bromate 5. That is also an indicator that the oxidation state of bromine is 5. And you can verify that by remembering that most times oxygen has an oxidation state of -2. There are 3 oxygens, so 3 multiplied by -2 equals to -6. And then the entire polyatomic ion carries a -1 charge. So therefore this -6 has to be counterbalanced by a positive 5. And that is why the bromate 5 ion is named in this way, because you have oxidation state 5 for bromine there. So +5 oxidation state for the bromate ion. The bromate ion is acting as an oxidizing agent in acidic conditions to form bromide ions. So let's fill in the other side of the equation, at least some of it. And put an arrow here, and we can put the bromide ion, which is Br minus. Yes, you're expected to know that Br minus is the bromide ion. The bromate ion was given to you earlier in the question. We are told that it's happening in acidic conditions. And the hint when you have something in acidic conditions is that you have to add hydrogen to this side where you have oxygen on, and on the other side you have to add H2O. Then you are very close to finishing the answer now. What you have to do is to check and see if the oxygen on this side is balanced with the oxygen on that side there. And you'll see that here you have 3 oxygens on this side, and on this side here you only have 1. So it might need some trial and error, but if you put in a 3 here, then this would be 3 oxygens, then 3 multiplied by 2, that gives you 6 hydrogens. So that is a sign that you should put in a 6 here as well. And now you can check and see if everything is balanced. In these redox reactions, not only do the atoms have to be balanced, but the charges also have to be balanced. So 1 negative charge here on the bromate ion and 6 positive charges here. That gives a total of 5 plus on this side, and then on this side you only have 1 negative here. So to make sure that everything balances in this redox reaction, in this half equation, you have to introduce a certain number of electrons on this side. And the number of electrons you need to introduce so that this goes from 1 negative and 6 positives to 1 negative on this side is 6 electrons. So these 6 electrons will cancel these 6 positives. You have 1 negative on that side, and you have 1 negative on this side. So if you're doing a half equation, you have to have electrons here. What you're saying is that in this half of the equation, 6 electrons are being taken. But those 6 electrons have to be coming from something else, which is not part of this equation. It's part of the other half. And when the two halves come together, you get the whole. So the half equation means you have to show that electrons are being taken up. If the bromide ions are being reduced, as you see, their oxidation state is going from 5 to -1. They are behaving as oxidizing agents, which means they have to be getting reduced. They have to be gaining electrons so that they would oxidize something else that is losing electrons. This is happening in acidic conditions, so you have to put H plus on this side. You have oxygen and hydrogen, so that has to be balanced by putting water on this side. And then all of the charges have to balance, and you can put in electrons. So once the redox reaction is a half equation, then you have to have electrons either on this side or you can have it on this side when you're dealing with a half equation. When it's in acidic conditions, the side that has the oxygen is going to have water on the other side, and the side that has the oxygen is going to have H plus on this side. And then you check and you ensure that all of the atoms balance and all of the charges balance.